Alright, today's lesson is dealing with probability of multiple events. In a lot of ways, we're just building, we can use what we already did last lesson. Probability is how many ways something can happen divided by all the total outcomes. That's still true, okay? So today we're just going to look at some different situations, but we'll refer a lot to what we did last lesson. So let's just talk, are things dependent or independent, okay? So dependent events are affected by, or we could say they depend on, previous choices. Independent event, not going to be affected by anything. Okay, so for example, let's say we're playing with toys. Okay, there's so many toys out there. Well, the choice I get, which toy I get to choose, depends on when I get a pick, right? So if other kids go before me, some of the toys are gone. So that's a dependent event. Independent, on the other hand, let's say we all flip a coin or we all roll a die and we want to see what number we get. Okay, if I get heads or tails on a coin, it's not affected at all by what you get when you flip a coin. So those are independent of each other. They don't affect one another. Let's just classify a couple examples. So choosing a member of a class and then choosing another member of the same class. Do those depend on one another or are they independent? Now, so the order is the key here. Because someone's already gone, well, then the next choice is affected by that, and so this would be dependent. That's kind of like the toy option, right? One of the toys is gone. In this case, it's a student, though. And so that is dependent. Choosing a marble out of a bag and then selecting another marble out of the same bag. Again, think about the toys. Hey, dependent as well, okay? Because one marble's already gone. So if I reach in again, I can't take that marble because it's already out of the bag. Okay, 2 rolls of a number cube. So I roll and I get a number. I get a 3. I roll again. Does that 3 that I already rolled affect the second one? Not at all. So these are independent of one another, okay? Tossing a coin twice. I toss a coin, I get heads. I toss it again. Does that heads that I just got affect the next one? Not at all. Hey, that's independent. Okay, hopefully that's kind of making sense. Now, you can find the probability of independent events by multiplying the probability of each event. Okay? And a lot of times, if you have a situation, you can just add up like we did last time. So let's look at an example. 2 standard cubes. Find the probability of rolling a 5 and a number less than 3 on the other one. So what's the probability of getting a 5? Well, that would be a 1 out of 6 probability, right? Because there's 1 5, there's 6 totals. And okay, so you got to get both of them, so that means you're going to multiply these together. A number less than 3 on the other cube. Well, less than 3, you got a 1 or a 2. So you could get 2 options out of 6. And so now we could just multiply these together. Now you might want to reduce this fraction right off the bat if you want. In fact, let's do that. So that'd be 1/3, right? So 1 times 1 is a 1 out of 6 times 3. So you have a 1 in 18 chance of getting a 5 and a number less than 3 on the other one. See how those are tied together? Okay, how about mutually exclusive events? These cannot happen at the same time. So for example, can I roll a 2 and a 3 on the same number cube at the exact same time? Well, no. Okay, those are mutually exclusive. You can't have both at the same time. And so let's just identify, and then we'll come back to this relationship. Being over the age of 35 and being under the age of 30. Well, can I be over 35 and under 30 at the same time? No. So these are mutually exclusive events. They cannot occur at the same time. Now, can I be over 30 and under 40? Yes. Okay? So those are not mutually exclusive events. Those can happen at the same time. Even numbers and odd numbers. So can a number be even and odd at the same time? Well, no. So those are mutually exclusive events. You cannot be even and odd at the same time. Multiples of 5 and multiples of 2. Is there overlap there? Well, multiples of 2. Let's see, 10. Well, there's a lot, but 10 is both the multiple of 2 and 5. So those are not multiply or mutually exclusive, okay? So you don't need to really worry too much about this relationship. Most of the time you'll be given information, you can just think your way through it. But if they are mutually exclusive, so we get an or in there, okay, we got A or B happening, then you add those together. Okay, so if they were independent, we could multiply them. But now you add the probabilities together. So for example, what's the probability of rolling a 2 or a 3? Okay, well, for a 2, I've got a 1 in 6 chance. For a 3, I have a 1 in 6. And so I add them together, right? And again, you could just think about that. Well, a 2 or a 3, well, there's 2 possibilities. They're out of 6. And so you get a 2 out of 6 or a 1/3 probability of that happening. All right, one more thing I want to talk about. Finding the probability of A or B when events are not mutually exclusive. Okay, when they're not mutually exclusive. So we get some overlap. So for example, on a number cube, find the probability of rolling an even number or a multiple of 3. That would be 3 and 6. Well, 6 is also even. See how that overlaps with the evens? So I can't just add this to this, because that would double up on some possibilities. So we have to subtract some possibilities away so we don't double count. Here's that general relationship. Well, probability of A plus probability of B, subtract probability of both. Again, you don't need to stress out about this. Let's just think about it. So on a number cube, find the probability of rolling an even number. Well, that would be 2, 4, or 6, or a multiple of 3. So that would add 3 to the mix, right? I'm not going to write 6 again. That would double it up. So that's 4 possibilities out of 6 total rolls. So that is a 2/3 probability of happening. See how you could just kind of think your way through that? So, you know, I wouldn't stress out about these relationships. Most of the time, what you're given, just think your way through it. How many ways could this happen? What are the total possibilities? And you'll be in good shape.